I hope you all are fine. So today's my topic will be on design of timber structures. So in my previous Google Meet class, I have told you the difference between timber and wood and what are the advantages of timber over other structural members like steel, RCC, concrete. So let us start with solid wood columns. Columns, are the vertical compression members. Now what are solid wood columns? These are the columns. These are also structural members which support load primarily by inducing compressive stresses along the grain. Solid columns consist of a single piece of wood and they can be rectangular or circular in cross section. Now what do you mean by grain of a timber? The grain is a term used to denote the direction of fiber of a timber in relation to the main axis of a tree or member. And when the direction of fibers of a tree is more or less parallel to the axis of a tree or longitudinal axis, then the grains are known as straight grains. And these straight grains are also known as parallel grains. Now columns are also of three types: short columns, intermediate columns and long columns. These solid wood columns are of three types. First is your short column. Second is your intermediate columns. And third is your long columns. Now to differentiate between these three types of columns, we should know a term that's known as slenderness ratio. Slenderness ratio. Slenderness ratio is S by D, designated by S by T in case of solid wood columns. And is defined as effective length by least dimension. Least dimension of the column. Right? Now we will define short columns. Short columns are defined as the columns when slenderness ratio, that is S by D, S is your unsupported length or effective length and this is the least dimension of the column, when S by D is not greater than 11. Means when your S by D ratio, when your slenderness ratio is less than 11, then the column is known as short column. Stress is equal to P by A is equal to FCP, where P is the load on the column and its units will be Newton. A will be your cross-sectional area in mm square and your FCP will be stress in compression parallel to the grains. condition for your short columns. You have to remember, when your slenderness ratio is less than 11, then it's termed as short columns. Right now it's your intermediate columns. Intermediate columns. Intermediate columns are defined as the columns when your slenderness ratio, that is S by D, is greater than 11, and less than or equal to K8. It's known as intermediate columns. Now what is this K8? This K8 is a constant and it depends upon E and FCP. Now E is your modulus of elasticity, but for wood, where E is the modulus of elasticity of wood, this will be given in your code, that is IS 833. These values will be given in this. This is the code for your timber structures. Modulus of wood in Newton per mm square, and your this FCP is permissible compressive stress in grains. Now FCP, you know FC is equal to, stress is equal to P by A is equal to FCP into 1 minus 1 by 3. This is your S K8 D raised power 4. This is the equation for permissible stress in compression parallel to the grain, and this is for your intermediate columns. Permissible stress in compression for intermediate columns is equal to FC is equal to force per unit area equal to FCP. This FCP you will get this value from code, that is this IS 833. 1 minus 1 by 3. This S is your unsupported length. K8 is a constant and D is a least lateral dimension. Now we have also a formula for K8. Now K8 will be calculated from the formula 0.702 E divided by FCP raised power 1 by 2. This E is your modulus of elasticity and this is your permissible stress in compression parallel to the grain. Now is your long columns. Long columns are defined as the columns when your slenderness ratio, that is S by D, this is your unsupported length or effective length divided by least dimension of the column, is greater than K8. It's termed as long columns. And for long columns, the permissible stress is determined by the following formula. This is your stress is equal to force per unit area is equal to 0.329 E divided by S by D square. Thank you.